The last method we're gonna use, well, this is, there's more methods, but I'm gonna find them and I'm gonna make videos out of it. This one is called finding the perfect square, and we're gonna use finding the perfect square. Finding the perfect square only means one thing, that we want to get the trinomial to look like this. And this is called perfect square because this is equal to a plus b times a plus b. And it's also equal to square root of a plus 2ab plus b squared. I call this identity, but its identities are used in trigonometry, not in math or algebra. But I like it. I like to use it because it's like a rule of thumb. It's like when you see like this sine squared of an angle plus the cosine of a square of an angle is equal to 1. That if we use our handy dandy calculator, since this is a super calculator, it has everything. So we go back to our mode, the math mode. Oh, I can't. Let me clean this up. Let's go to math mode. And when we go to trigonometry, this is not trigonometry. Yes, this is trigonometry, sorry. When we look for our identity, here it is. Sine of square of an angle plus a cosine of a square of an angle is equal to 1. There's another one that says tangent of an angle times the cotangent of an angle is equal to 1. Another identity is the tangent of an angle is equal to the sine of the angle divided by the cosine of the angle, which is equal also to 1 of the cotangent of the angle, and so forth. Okay? So those are identities. We call them identities. And there's a whole bunch of them. There was a time where I was doing a lot of this stuff, finding out why is the fact that the sine of an angle, the sine of a square, the sine square of an angle plus the cosine square of an angle is equal to 1. That's my objective, not solving problems, but finding deriving these formulas and see why the case. That's the scope of my lessons, but I'm not there yet. Soon we'll get there. So this problem is we're gonna use in finding the perfect squared. We're gonna use y equals minus. We're gonna use x squared minus 8 x times x minus 6. If we try to, let's say that we try to find the factors, something is speaking. know what speaking. Maybe I'm just hearing things, but it looks like a phone is speaking somewhere. Anyway, if we try to find the perfect, try to factor this out, we have to find two numbers that multiplied will give us 6, and then subtracted to give us 8. That looks like let me see, 2 and 4. Yeah, 2 and 4. And in order to get multiplied, no, that's not gonna work. That's not gonna work. What about 2 and, I don't know, 3 por 4, 8. No, 3 por 4 is not 8. Okay, I can't come up with factors, one way of trying to find factors is trying to find all the factors of 6, which is 2 times 3 and 1 times 6. You can see that those are the only factors that we can come up with, 2 times 3 and 1 times 6. And on the 8, it will be 2 times 4, and that's about it, and 1 times 8. But, if you try to find the factors, you can see that there will be no common factors for sure. For sure, because none of these are the same as this. And so it's factoring out, it's not so easy. It's not straightforward. So we're going to use the completing the square. So in completing the square, we do this. We write this, we separate the 6 a little bit, put it away a little bit. Remember, we are setting this equal to 0 because we want to find the roots of the equation. Okay, so we have to find this number, the half of that number, so I have to 8 divided by 2, and then we square it and we put it there, here. So that will be 4 squared. But because we're adding 4 squared, we also subtract 4 squared, because we are not doing anything to the equation. We are changing the looks, but it is still the same. But we can use this 4 here to complete the square. So we will write x, and this is being a minus because of the minus sign here, minus 4, and x minus 4, and then we write the rest of the stuff, which is 4 squared, which is 16, and we have 6 here is equal to 0. This we can write as x minus 4 squared, and 6 plus 6 is 12. So this means that this will be 22 minus 22 equals 0. And to find the roots, we have to get x by itself. To do that, we take the square root of this side and the, well, first let's move the minus 22 to the other side, and now we square both sides, and we get, when we square this, we get, this will cancel out with the root and leave behind x minus 4. And on this one, we have 22 22. What are the factors of 22? Well, we can use our handy dandy calculator. You know, I think it's on. I think it's only have one. If we write 22 and then we go to more, we see the factors. See 11 and 2. And so even when we split it, we cannot make this square root smaller. I mean, we can write it as a square root of 2 times the square root of 11. But that is not going to make it easier. So we leave it like that. So the x value, remember we have to, let me rewrite this thing. X, we still have not finished. X is equal to square root of, we have to put the 4 on the other side, so we get 4 plus or minus. When we take a square root of a number, the solutions can be two numbers that are positive or two numbers that are negative. Yeah, that's why plus or minus. So that means that the x1 will be equal to 4 plus the square root of 22, and x2 will be 4 minus the square root of 22. And you can see that trying to get the factors, you know, like we were trying to do here, it's very difficult. I wouldn't say impossible, but you have to sit there forever trying to find numbers that are going to be obviously, you know, decimal. How to say, integers? I don't know. I don't remember what they will call it, with numbers with fractions. You know, like 2.287, something like that. I don't know. We can call it. Well, forget it. We'll figure it out some other time. We can do this by hand. It's say square root of 22 is equal to 4.69. So x1, and I'm going to put it here because I don't want to occupy my page. I say x1 is equal to 4 plus 4.69, which will give us 8.69, and x2 will be equal to 4 minus 4.69, which will give us minus 0.69, negative. Okay, the vertex, we will have to calculate the formula, and I will put it here. for the vertex, we will have to use the formula minus b divided by 2a, which is equal to minus 8 divided by 2 times 1. So this is equal to 4. That's the x value. And the y value, in order to find the y value of the vertex, what we do is that we take this number, we plug it into the equation, and we get the value of y. You know, we could do it, but it's just time consuming. So I don't want to. Basically, we have to calculate when y when x is 4, and that will be 4 squared minus 8 times 4 minus 6. And if we use our handy dandy calculator, we get 4 squared minus 8 times 4 minus 6 is equal to minus 22. So y of x equal to 4 is equal to minus 22. So the graphic for something like that would have a vertex situated at 4, and minus 22. So if we go and assume that this is 1, 2, 3, 4, and that's where the vertex is, and assume this is minus 22, that will give us this point here, and one root is, where are my roots? Where are my roots? Okay, so the one root is 8, and like I said, you know, it doesn't, you know, I don't have enough space to draw it correctly. And minus 69 will be somewhere in here. So the parabola will be somewhere like this. If we use our handy dandy calculator, we go to the trinomial mode, we punch 1, enter, minus 8, enter, and minus 6, enter, and we hit again, and then we get the first root, this one, the negative root, and the other root is this one, and the vertex is 4, the x value, and the negative, the y value is negative 22. I don't know if you can see it. Let me go through that again. You can see the calculator is showing the roots. The other root, the x value of the vertex, and the y value of the vertex. Now we can graph it. We go to, we don't have to go there. We're mode, yeah, we go to math mode, and we go to the second key, we go to graphics. Oh shit, I'm missing. I have to go back to this mode here, and then I go to the second and go graph, and here it is. Oops. And you can see that if we tell the calculator to show us the roots, those are what the roots are, and with fractional numbers, which are, you know, I have them here, 8.8 8.69 and minus 6.69, and that's what is here and there. And this point here, we can hit the extrema, and you can see that it's 4 minus 22. Okay, so that's it. That's it for this problem. Then that's the finding the perfect square. Thank you so much for watching.